Good evening students. In the last class we solved the numericals related to Doppler effect and interference of light. In today's class we are going to solve the numericals related to diffraction of light. Before solving the numericals related to diffraction of light, first we have to know what are the important formula used in case of diffraction of light. What are those important formula? First one, in order to find the angular position of diffraction minima. So what is the formula used to find the angular position of diffraction minima? Angular position of diffraction minima. Angular position of diffraction minima. Then, so what is the expression for path difference? The path difference can be represented by x, that is equal to d into sin theta. It is the expression for path difference. And in case of diffraction minima, the path difference is n into lambda. Then n lambda is equal to d sin theta. What is lambda? Lambda is the wavelength of the light used, and what is n? N is the position of the diffraction minima, and what is d? D is slit width, and theta is the angular position. Now for the small angle, sin theta can be taken as theta. Hence I will write d into theta, that is equal to n into lambda. But what we required? We required theta, means angular position of the diffraction minima. Then theta is equal to n into lambda by d. And it is the formula used to find the angular position of the nth diffraction minima. Okay, if n is 1, it is first minimum. If n is 2, it is second minimum. If n is 3, it is third minimum. Okay, now what is the linear position of diffraction minima? Now it is the angular position of diffraction minimum. Then what is the formula used to find the linear position of diffraction minima? So linear position of diffraction minima. Once again, I will write the path difference in case of diffraction minima. So that is x is equal to d sin theta. So one thing remember, what is d here? D is slit width, theta is angular position. Now x is equal to, instead of x I will write n into lambda, because path difference in case of diffraction minima is n into lambda. Then d into sin theta. In order to find the linear position of the diffraction minima, I will take, instead of sin theta, tan theta. D into tan theta, because for small angle sin theta and tan theta both are equal. For example, for small angle sin theta is theta and tan theta is also theta. That is why instead of sin theta I will write tan theta. See here, it is single slit and it is screen, and on the screen we will get a diffraction pattern. This is a diffraction pattern. In order to find the first minimum, so the linear position of the diffraction minimum from the center of the screen, that can be taken as y, and the distance of the screen from the single slit can be taken as d, and angular position of this minimum can be taken as theta. Then tan theta is equal to opposite side divided by adjacent side, means y divided by d. Then wherever tan theta is there, I will write that is y divided by d. D into y divided by d. So don't confuse here. Small d is slit width, but capital D is distance of the screen from the single slit. Now it is n into lambda. But what we required the position, linear position of the diffraction minima. So hence I will write directly y is equal to n lambda into capital D divided by small d. So remember the terms here. So what is n? N is the position of the diffraction minimum, lambda is the wavelength of the light used, capital D is the distance of the screen from the single slit, and d is the slit width. D is the slit width. This is about the angular position of diffraction minima and the linear position of diffraction minima. Now let us move to the next formula, angular position of diffraction maxima. Diffraction maxima. Maxima means here intensity is maximum. Then, so again path difference is x is equal to d sin theta, but path difference for the diffraction maxima is 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2. Now, again for the small angle sin theta can be written as theta, then d into theta, that is equal to 2n plus 1 into lambda by 2. Then what we need? We need the angular position of diffraction maxima. Hence theta is equal to 2n plus of 1, 2n plus of 1 into lambda divided by 2d, into lambda divided by 2d. So this is the formula used to find the diffraction maxima. If n is 1, it is first maximum. If n is 2, it is second maximum. If n is 3, it is third maximum, and so on. Next, linear position of diffraction maxima. Linear position of diffraction maxima. Okay. Now, again, what is path difference for the diffraction maxima? One thing remember. So path difference for the diffraction minima is n into lambda, and path difference for the diffraction maxima is 2n plus of 1 into lambda by 2. Now 2n plus of 1 into lambda by 2, that is equal to d. Instead of sin theta I will write tan theta, because for the small angle sin theta and tan theta both are equal. Then tan theta is nothing but it is again y by d. Here y is nothing but linear position of the diffraction maxima. Then I will write it is a d into y by d. So this d is slit width, this capital D is the distance of the screen from single slit. Then it is 2n plus of 1 into lambda by 2. But what we required? We required the linear position of the diffraction maxima, means intensity is maximum. Now y is equal to 2n plus of 1 into lambda by 2 into lambda by, sorry, this d comes to the numerator, lambda into d divided by 2d. Okay, this is the formula used to find the linear position of diffraction maxima. If n is 1, it is first maximum, n is 2, it is second maximum, n is 3, third maximum, and so on. So this is about the angular position and linear position of diffraction maxima. Now let us find the width of the central maximum. What is the formula used to find the width of the central maximum? Third one, width of the central maximum. Central maximum. Now how to find the width of the central maximum? See here, this is diffraction pattern. At the center of the screen there is a maximum intensity, that is called central maximum. Now this is a diffraction pattern. At the center of the screen the intensity is maximum, hence it is called central maximum. Now we have to find the linear width and also angular width. So this is angular width. Okay, this is angular width and this is linear width. So from the center of the screen, the distance of the first minima can be taken as y1. Again from the center of the screen, the distance of the first minimum is also taken as y1. So because both distances are same here, both positions are same, so that is why y1 plus y1, that can be taken as 2y. So y1 plus y1 means this y1 and this y1 both are equal na? That is why instead of y1 and y1 I will write y plus y plus y, that is 2y, then 2 into then what is the linear position of the first minimum? The first minimum, what do you mean by linear width here? It is the distance between first two minima on the both sides, What is the linear position of the minima? Diffraction minima. So that formula is, already I said that is d sin theta is equal to n into lambda, then theta can be written as y by d, then n can be taken as 1 because it is first minimum. This is first minimum and this is also first minimum, means it is lambda. Now what we need? Y is equal to y is equal to lambda into capital D divided by small d, Now so wherever y is there, I will replace that y by lambda into d divided by d, lambda into capital D divided by small d, then it is linear width. Linear width is equal to 2 into lambda into capital D divided by small d. So sometimes instead of capital D we are going to take focal length of the convex lens, that is 2 lambda f divided by small d. So one thing remember, what is small f here? Small f is nothing but it is the converging lens, means convex lens used in case of diffraction by single slit, then 2 lambda into f divided by d, then lambda is nothing but wavelength of the light used, then it is the formula used to find the linear width. Then what is the formula used to find the angular width? Then it is theta, then this is also theta, then theta plus theta, that is 2 theta, then this 2 theta gives the angular width of the central maximum. Then what is the angular position of the first minimum? First minimum is, that is, instead of sin theta I will write theta, because for the small angle sin theta can be written as theta, then d into theta is equal to n into lambda, then theta is equal to n into lambda by small d, but for the first minimum n value is how much? 1, hence angular width, that is 2 theta is equal to 2 into theta is how much? N lambda by d, but n is 1 for first minimum, that is why I will write lambda by d, then it is 2 lambda by d. Then it is the formula used to find the angular width of the central maximum. So remember these two. Here 2 theta is nothing but angular width, and here this 2y is nothing but linear width. So remember these two formula. So linear width is 2 lambda into capital D divided by small d, otherwise 2 lambda into f divided by small d, where f is nothing but focal length of the convex lens. And what is the angular width formula? That is 2 theta is equal to 2 lambda by d. What is lambda? Wavelength of the light used, and what is small d? It is slit width. So based on this formula we are going to solve some questions. Solve the questions related to the diffraction of light by using the previous formula. So first question, a slit of width a is illuminated by white light. The first minimum for red light. For which color there is a first minimum? For the red color. The first minimum for red light and its wavelength given 6500 angstrom will fall at theta is equal to 30 degree, then A will be, means what we have to find? We have to find the slit width. Solution. First write the given wavelength of the red light given, that is 6500 angstrom. 6500 angstrom. In terms of meter, it is 6500 into 10 to the power of minus 10 meter. And the angular position of the first minimum given, that is 30 degree. 30 degree. 30 degree. Then what is our aim? Our aim is to find slit width. Already I said that what is the formula for path difference? Formula for path difference is x is equal to d sin theta. x is equal to d sin theta, but it is first minimum, means diffraction minimum. So what is the path difference for diffraction minimum? That is n into lambda. N into lambda, that is equal to d into sin theta. Then instead of d I will take a, because here slit width given as a. So instead of d I will take a. Then a is equal to, our aim is to find a, means slit width. Then a is equal to n into lambda divided by sin theta. So for the first minimum n value is how much? 1. So n can be replaced by 1. Then wavelength how much given? 6500 into 10 to the power of minus 10. Then sin 30. Sin 30. So sin 30 is 1 by 2. 6500 into 10 to the power of minus 10, this is divided by 1 by 2. Then 2 comes to the numerator. Then 2 into 6500 into 10 to the power of minus 10 into 10 to the power of minus 10. Then 65 2s are 65 2s are, that is 130, because 2 5s are 10 and 2 6s are 12, 12 plus 1 30, 13, then it is 130. 1 3 2 zeros. Okay, so means it is 13,000 into 10 to the power of minus 10. So I will replace the decimal point after how many digits? 1 2 3 and 4. In which direction? Left direction. That is 1.3 into 10 to the power of plus 4 into 10 to the power of minus 10. So 10 to the power of 4 into 10 to the power of minus 10, 10 to the power of minus 6. Then 1.3 into 10 to the power of minus 6 meter. And 1.3 into 10 to the power of minus 6 means here 1.3 micrometer or 1.3 micron. 1.3 micron. So the given options, first option 3250 angstrom, second option 1.3 micron, third option 6.5 into 10 to the power of minus 4 millimeter, and last option 2.6 into 10 to the power of minus 4 meter. Which is correct answer? 1.3 micron is the correct answer. Okay, this is about the solution related to the given question. Now let us move to the question related to again the diffraction minima and maxima. Light of wavelength 5000 angstrom is incident on a slit. The first minimum of diffraction pattern is observed to lie at a distance of 5 millimeter from the central maximum on a screen placed at a distance of 3 meter from the slit. Then width of the slit is, means again we have to find slit width. So once again listen here. Light of wavelength 5000 angstrom is incident on a slit. The first minimum of diffraction pattern, the first minimum of diffraction pattern is observed to lie at a distance of 5 millimeter from the central maximum, on a screen placed at a distance of 3 meter from the slit. Means the screen is placed at a distance of 3 meter from the slit. Then the width of the slit is, what we have to find? We have to find the width of the slit. Here it is a single slit and it is width of the slit. Width of the slit you can take D or A. Then it is screen. Then the first minimum of diffraction pattern is observed to lie at a distance of 5 millimeter. Then supposed to be, I will take it is first minimum. It is first minimum. And which is lie at a distance of means linear position given, that is y is equal to, so that is how much given? 5 millimeter from the central maximum. It is central maximum. It is central maximum. Okay. The first minimum of the diffraction pattern is observed to lie at a distance of 5 millimeter from the central maximum on a screen placed at a distance of 3 meter. Then what is the distance of the screen from the slit? That is 3 meter. It is capital D. Yes, this is capital D. Then what is our aim? Our aim is to find the width of the slit. Then what is the formula used to find the linear position of the diffraction minima? So what is that formula? Already I said that y is equal to n into lambda into capital D divided by small d. Use this formula. Then what is given? Y is given, means linear position of the first minimum is given. That is how much? 5 millimeter. And n is 1 because first minimum. Then wavelength how much given? Wavelength 5000 angstrom. Then capital D is 3. Then find small d. Then by using this formula. Then y is equal to n into lambda into capital D divided by small d. Then small d is equal to n into lambda into capital D divided by y. Then substitute the values. N is how much? 1 because first minimum. 1. Then wavelength 5000 angstrom. 5000 angstrom can be written as 5 into 10 to the power of minus 7 meter. 5 into 10 to the power of minus 7 meter, because 5000 angstrom is nothing but 5000 into 10 to the power of minus 10. So 5000 into 10 to the power of minus 10 can be written as 5 into 10 to the power of minus 7. D is 3. D is 3 divided by, so the position, the linear position of the first minimum from the central maximum, that is 5 millimeter. 5 millimeter means it is 5 into 10 to the power of minus 3. Then 5 get cancel. What remaining now? 3 into 10 to the power of minus 7 into 10 to the power of plus 3. 10 to the power of minus 3 taken to the numerator, that becomes 10 to the power of plus 3. 10 to the power of minus 7 into 10 to the power of 3, 10 to the power of minus 4. 3 into 10 to the power of minus 4. This is in meter. But options given here, so those options given in centimeter, those options given in centimeter only, means we have to convert this one to centimeter. Now let us replace. There is a decimal point. So I will displace this decimal point after one digit in which direction? Left direction, means that is 0.3. Now it is 10 to the power of minus 3 meter. Again I will displace this decimal point in left direction after one digit. Again it is 0.03 into 10 to the power of minus 2. Then 0.03 into 10 to the power of minus 2 is nothing but that is 0.03 centimeter. So slit width is 0.03 centimeter, because 10 to the power of minus 2 meter means it is centimeter. So this is the answer related to the, this is the answer related to given question. Now next question. The width of a slit is 0.012 millimeter. So the width of the slit given, that is 0.012 millimeter. Monochromatic light is incident on it. Okay. The angular position of first bright line. First bright line means here first diffraction maxima. First diffraction maxima. Bright line means maxima. So dark line means minima. The angular position of the first bright line is 5.2 degree. The wavelength of the light incident is, means what we have to find? We have to find the wavelength of the light incident, and sin 5.2 degree value is given, that is 0.0906. First bright line means here it is first diffraction maxima. And here the angular position of the first diffraction maxima is given, means the angular position of the first bright line is given, that is how much? Theta is equal to 5.2 degree. 5.2 degree. Then slit width is given, means width of the slit is given, that is D is equal to 0.012 millimeter. Millimeter in terms of meter, that is 10 to the power of minus 3 meter. Then what is our aim? Our aim is to find the wavelength of the incident light. So here how to find the wavelength of the incident light? What is the formula used to find the angular position of diffraction maxima? So that is theta is equal to 2n plus 1 lambda 2n plus of 1 lambda divided by 2d. Then what is our aim? Our aim is to find lambda. Now, so it is first bright line. First bright line means n is how much? That is 1. Then 2 into 1, 2, 2 plus 1, 3. Then 3 lambda by 2d. Then this is equal to, sorry, I will write it is sin theta. This is sin theta. Because here d sin theta is equal to, it is the formula used to find the angular position of the diffraction maxima. So that is 2n plus of 1 lambda by 2. This is the formula used to find the angular position of diffraction maxima. I will take this d to the right hand side, that comes to the denominator. So sin theta is equal to 2n plus of 1 into lambda by 2d. Then it is sin theta. Then what is our aim? Our aim is to find lambda. Our aim is to find lambda. Then lambda is equal to 2 into d. So sin theta, 2 into d sin theta divided by 3. Now let us substitute the values. Again, what are the given values? So those are 0.012, it is slit width, and the angular position 5.2, and its sin value is given, that is 0.09016. 2 into 0.012 into 10 to the power of minus 3, because it is written here 0.012 into 10 to the power of minus 3, and sin 5.2 given, that is 0.0906 divided by 3, then the answer is 0.0007248. On solving this one, you will get this much answer, 0.0007248 into 10 to the power of minus 3, Then I will displace the decimal point after how many digits? 7 digits. 1, 2, 3, 4, 5, 6, 7. 7248 into 10 to the power of minus 7. Because here the decimal point is displaced in the right direction. Okay, decimal point is displaced in which direction? Right direction, and after how many digits? After 7 digits. That is why 7248 into 10 to the power of minus 7 into 10 to the power of minus 3. Then 10 to the power of minus 7 into 10 to the power of minus 3, 10 to the power of minus 10. 7248 into 10 to the power of minus 10 meter. So it is 7248 angstrom. Then this is the answer. Then the options given: 6040 first option, 4026 second option, and third option 5890, and last option 7248. Then option 4 is the correct. So these are the some questions related to the diffraction of light.